looking at very thin sections of tissue. And one of the easiest ways to look at structures and things is to embed them in paraffin. And paraffin is simply another word for wax. You're going to embed them in wax. And so as you can imagine, the process of putting something into wax until you get a block, which might look something like this, and then taking slices of those blocks. You know, it's a series of steps that you have to go through. Unlike a lot of what happens when you do laboratory work, I'm sad to say, I'm not going to wood, I do kind of feel like the whole process of embedding and getting really nice serial sections, there's a little bit of magic that goes on in trying to make sure everything works out properly. At the very early stage, if you have a whole organism and you're getting samples from it, or you have a whole organ, you might need to decalcify it. I mean, one of the things that I've worked on is sea cucumbers, and they have little ossicles embedded in their body wall. And so if you have any sort of hardened structure, if you're doing paraffin histology, you need to get rid of it. And so to do that, we do something called decalcification. So you basically have some sort of chelating agent which will attach to the calcium carbonate or calcium phosphate and basically break it down. And it should leave everything else around it undamaged. So that's the idea behind it. And then what you'll do is you'll wash that material away, and then you'll go through a series of steps referred to as dehydration. Because you're going from something which is washed, you want to take it as much of the water out of it as possible, and then go into alcohol. And so you can see there's some changes of 100% ethanol here. And then you use something which basically is meant to be compatible with the paraffin wax. And so there's a series of different names. Histoclear is one of the ones that I think we have. Yeah, I think that's the one. Now, a lot of these things that, you know, I mentioned in here, and you guys know about, you know, ethanol, we've worked at various stages of that. This stuff here used to be something called xylene. You guys heard about xylene, or have you worked with xylene? Yes, no, maybe. Okay, xylene is nasty stuff. You know, a lot of the chemicals that are used in science initially were fairly sort of, you know, nasty things. You definitely wanted to sort of, you know, keep your gloves on when you did it. But if you look back in some of the earlier, you know, literature for it, they didn't believe in using gloves. They just weren't widespread. So people started having weird mutations, you know, and stuff like that. That's when they knew they needed to really work on it a bit more. So we use something called Histoclear, you know, which is going to be medicinal with paraffin. And then you put the tissue into a little vial. And so all of that will literally take a day to do, unless you have some sort of fancy automation in which you can do that part with. After that, what you want to do is to have the wax go all the way through the tissue. So if you take a look at this block, and I can sort of pass it around, but even from in the back of the room, you can see that the wax is clear, and you can see some darker tissue that's there. All right, so the idea is that if you're going to section through this, you need to make sure wax is penetrating all the way through. And the best way to do that is to heat the wax up. And so that's what you're seeing in these steps. So this would be one series that you put tissue through, but you could also start with the tissue here. So you go from wax 1 to wax 2 to wax 3, and then you would embed it. And once you've embedded it, you basically have wax that's been poured into a mold, and you put the tissue inside and you position it the way that you want the tissue to be positioned for sectioning. One of the common things that sort of comes up when you are doing paraffin histology is what sort of shape you know, do you want the tissue to be in? Well, because you're essentially taking slices off of it, you want to make sure you have a broad enough base, because if the bottom part is too small, then that means as it comes into contact with the knife blade, it's not going to be able to disperse some of that force. So there's a characteristic shape that you want these to be, and there's no marker here. Do you have a marker?
No, there's no.
No, there's not one up there.
Okay.
Can you give me a pen? Ah, he's a winner. So what you typically will do for a block is to have it, which reminds me of a cesto sort of worm, if I think about it. This is the way you want to shape the block to do. So once you have the tissue embedded, you take out a razor blade and you shape it to have this appearance. And then you'll have your piece of tissue inside of it, and you'll get sections of that.
Sorry, is that an aerial view or a side view?
This is a front view. So when you take a look at this, you'll see that it's in that shape. Actually, this is not very shaped very well. After you have a piece of tissue in the block, after a while, as you're cutting deeper and deeper into it, you kind of lose some of that excess shape. But it should be a profile so you can cut into it. And this bottom part down here is what will come into contact with the blade. So as you section it, that's what it'll do. One of the unique things about paraffin histology is that you can have what's called serial sections. And by serial sections, it means that you have multiple sections that are attached to each other. And I'm not an artist, and I usually laugh, as I'm drawing pictures. And so this one won't be that much of a stretch to get a little bit out of you guys. So as you continue to take that slicing motion of the microtome, you'll have sections which are attached to each other. Generally, when you're working with, already slides which are already done, there's only one slide up there. There's only one section of tissue. But if you're doing this for research purposes, you want to know what the structure looks like from the beginning to the end. The ability to have multiple serial sections is something that's really useful. When I look back over some of my dissertation research, if I did like an anterior section of a sea cucumber and went all the way through it, I might have 70 slides. And each slide might have 4 to 5 serial sections up there. So for research purposes, thank you, that does get you a lot, in one go around from there. So continuing on for that, I'll give you have instructions for how to attach a block to one of the shaping ones. So what you have here is, and I'll pass this around, is the block of wax which has a tissue embedded into it, and it's attached to this plastic tab. And so this plastic tab is what you'll actually put into the microtome, to do your section. So let me pass this around before I attach it to one of those. So again, we want it to look more like a trapezoid than anything else. And then there's also a couple of other steps which I'll probably try to show you guys on a different day. Well, after you have a serial section, how do you make it adhere to a microscope slide? There's some intermediates that happen in there as well. And then the last part that I wanted to mention, just sort of, to get you in the frame of mind for the overall process, is being able to see the tissue. So for the first part of paraffin histology, you're trying to get the tissue onto the slide. Well, once you have the tissue onto the slide, what do you do with it? We're talking about really thin sections, and so even though you can see the tissue looks dark and matte, if you have a section which is 5 to 10 microns thick, which is not all that thick, it's going to appear to be an opaque kind of color. You're not going to have any real significant coloration associated with it because it is so thin. And so that means that you need to do some sort of staining protocol. And so this gets into a little bit of chemistry if you are, so inclined. But there's a couple of standard staining protocols in which you'll see used. Have you guys heard of H&E? No? Okay. The standard stain, which gives most things a pink to purplish range of color, is called hematoxin and eosin. And there's probably maybe 60 different variations of H&E. But a basic tissue that you might see on a microscope slide might have HE in one of the bottom corners, but if the tissue appears anywhere between, pinkish to purplish, it's an H&E stain. So that's one of the standard ones which is typically done for paraffin histology. Another one is a trichrome stain, and the trichrome stains, they're my favorite because they're just so pretty. The trichrome stain, you basically have 3 different colors that are associated with it, and the overlap of those 3 different colors gives you a good amount of variation that you'll see. So this is an example of the different chemicals. And then you have a staining protocol. And the staining protocol, you're basically taking a microscope slide which has tissue on it, and you're taking it through a series of steps. Depending on your protocol, you may have as few as 4 or 5 steps, but you might also have 20 or more steps. And that's what this one has. Citrusol is the older version of the histoclear that I mentioned previously. So previously, when you go back 20 years, you would have been using xylene, which is much more toxic. This actually has that orange clean smell. You know how a lot of the cleaning things now have that orange scent to them? They're using a variant of orange oils to get the same effect. So you would, all right, I'm good. So you would take that slide and you would go through each one of these steps consecutively for a given amount of time. And at the end of it, what you would have is something which is ready to be cover slipped, and you can look at it. So there's multiple sort of, steps which are associated with actually going into the process of making a slide that can be used for teaching purposes. So all the slides that you've used for organismal, developmental, neuroscience, they've basically gone through a process to get to that stage. And that's what paraffin histology sort of sets the stage for. So you can look at histology from 2 different viewpoints. One of them is the laboratory processes which go into actually making microscope slides. And the second thing is being able to identify structures which you can find on microscope slides. And so usually for this course, we do a combination of both. We want you to be aware of what goes into the process of making slides. And if time permits and people are so inclined, you'll have the chance to make some. But also we want you to be able to identify different things from microscope slides. And that goes back into looking at cells, tissues, organs, structures. So that's sort of like kind of take you full circle, process. Now, one of the things which you'll use if you're actually making slides will be microtomes. And so both of these are, they're the same model. These are microtomes, which can be used to go through and to take the tissue to actually put it onto a slide. So I'll give you a very quick run through. These will be around, and you'll have more time to work with them later. But I just wanted to give you a very sort of simple, quick overview. And by trial and error, I put together a series of instructions. And so, since I won't be in the room when you do it, you guys can give some feedback on just how well this makes sense. So I think you might have it in front of you now. Yes, so it's this one. All right, so how to use the microtome. So if you take a look at this, on one part, it has check supplies. So if you're actually going through and you're going to go through the entire process, these are all the things that you'll want handy, because you don't want to go through and make slides, have tissue section, and then you're like, okay, so I have tissue that's hanging off of my forceps. What am I supposed to do with this tissue now? So you want to make sure you have everything, right there and ready to be used when you are actually going to make it. And these other parts talk about positioning the specimen block and then actually, sectioning itself. So positioning the specimen block is on one side and sectioning is on the other. So I'd have you come here very quickly. I'm going to do a super quick and dirty version of how to do this very quickly. No, I'm just going to do this super quick because I was supposed to be somewhere. All right. So for this, and this is these machines are just a little bit temperamental as well. So these are sort of like the major parts. One of them is this whole area where I talk about positioning the block, you know, that's on the stub. You'll have something which will already be, usually it'll be attached to this, and this is what you'll actually put up here. So this is the first part. And you want to sort of, you know, move this back a little bit more so it's kind of out of the way. Up here. So this part moves forward and back. And so what you'll want to do, this really should be reshaped. So you move this forward, and as you let it go, it's locked into place. And so part of what ends up happening is that as you look at the tissue, you kind of have to, I'm not a sailor, but I kind of think of this, you know, as in sort of 3 dimensions. And I'll use a slide box, it's a bit larger. So if it's oriented this way and you're trying to take sections through it, you're not getting a flat view of the tissue. So you want to make sure that you move the block so that this is going to be in alignment with the knife blade here. So part of what you'll do with these other controls here is you can loosen them up, and then you can rotate. You can rotate this. So there's a certain amount of positioning that has to go on with this as you get ready to do it. So whenever you take it off and you put it back on, if you've reshaped the face into that trapezoid shape, you want to reposition it. So at multiple points, you'll want to make sure that it's positioned properly because you want it to be oriented such you can make a clean section going all the way through. This is a flat which is meant to sort of protect your hand. With this stuff, these are razor blades essentially. So you gotta be careful around razor blades. But at the end of doing it for a semester, you know, you get much more comfortable with that. So I'll take this off. See if I can get it to slide out. Don't do this. So this is what it looks like right there. So it's just a razor blade. And initially, what you'll do is you can just start the sectioning and have this come into the contact with the block at any point along the way. Again, you want it to be perfectly aligned or as close as possible. But as you go through and you do the sections, sometimes what will happen is you'll be a scrape on it. And so what you'll want to do when it comes time to get your perfect, you know, serial sections, you'll want to get a clean section of it. So typically, you'll put this up here, you'll use it in one area, you might see that there's a scratch on it, and you'll move it over. And so you'll move it over until you use most of the blade, you know, at the time. And that prevents you from, you know, using too dull a blade, but also it sort of maximizes your space, you know, with it. And so this is one of the levers, and I have somewhere, I think, a separate sheet that goes through the different parts of it. So this is what you can use to sort of clamp it in. If you're not actively sectioning, what you want to do is to put this up here to protect yourself. And the other thing which you can do is you can also take this block and rotate it some as well. Usually once you have it oriented, it's usually fine for a while. But most of these are all sort of movable parts, and you want to make sure they're normally locked down unless you don't need them to be. But you don't want to have this undone and then decide you're going to move this from one location to another, and then this go flying off, and then this is not attached, and so then it goes across, and it, you know, it's a little bit boring, right? And it cuts off somebody's foot or something. I know that's not really going to happen, but I think you kind of get the picture of what I'm trying to paint for it. This particular one allows you to move this part up and down. So initially, you can move it so it's fairly close, but what you don't want to happen is for the overlap to be too much. So as a cautionary tale, again, this one isn't going to be horribly scary, cautionary tale. If there's too much overlap when you go through and you do this, and that wasn't, sorry. If I were to take this down, and you see how much of an overlap that is between the blade and the tissue? If I were to take that through, I chop off a big chunk of tissue. I didn't have damage my sample. So for any time that you have it up here, you don't want it to be too close. You want it to be just close enough that it will take you a little amount of time to go through and to get some nice samples for it. Now, having said that, it can take a little bit of time to actually reach where the tissue is. Make sure things are organized properly. You've got the paraffin shaped in which you want the trapezoid shape. And so instead of just doing this whole process manually, which is what I'm doing right now, there's a wheel over here. I don't need the wheel around. So you can do this manually. And if you have concerns, you think the blade might be scratched, that is the best way to do it. But you can also make this an automated process. So let's say that I have a new block on, I'm not even getting all the tissue when I go through. So what I can do is to set a timer, not for too long, like maybe 3 minutes, enough for me like to go wash my hands or something like that. You can set a window, and what that window will do is it'll roll it through, slow it down, it'll move slow, 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 and then it'll go fast to get back up to the top. So this is an automated one. The earlier ones were not automated, and you had to do it all by hand for it. So you can set what's called the cutting window, and that's what this button is for. It'll set a cutting window for you to slow it down, and it will speed up, on the backside. And if you have serial sections which are coming off of this, you'll basically have, as this comes into contact with the tissue, you'd have one section here. As you move this around, so as you rotate it around, it comes into contact with the tissue, you have another one. And so basically it would be trailing its way down. And you use a pair of forceps to pick it up and to put it onto a microscope slide. And after you have it on the microscope slide, there's a separate piece of equipment called a slide warmer. And you put it onto a slide warmer once you add some water to it. And as the water evaporates, you now have tissue attached to the slide. So that's a very quick overview of what goes into making microscope slides. To a certain extent, this is just kind of like, sort of coming out of my mouth. But as you have an opportunity to read the instructions here, read the little part that's in your textbook, there's also different websites you can go to for classes that are teaching this. And they can also give you some additional ideas on how it's supposed to proceed. And I can come back and help some of you again with what goes into it and getting you started on actually making some sections. Any questions? All right, I look forward to my next visit to your class. And I'll see you around. You're welcome.
Thank you, Dr. Bain. Appreciate that.